Parts A and B for each question are straight achieved parts. In the first one, common question, we will use the conjugate. Now we can do that with the surds. We also do a similar thing with complex numbers. So we change the sign on the denominator, use the same term top and bottom, and then we're going to expand everything out. The idea of the conjugate will always give this denominator down here. We just get the difference of the two terms squared for the denominator. So it's square root 7 squared, take away square root 5 squared. And on the top line, that simplifies to the 12 plus 2 square root 35. Be careful when you do some cancelling in this sort of question. You've got to take the 2 out as a common factor from both terms on the denominator, on the numerator. So the 2 comes out the front, and you get 6 plus square root 35, and then the two 2's can cancel. Now, in question B, our first step is going to be to read the coordinates for points A and B. So B is 3 across and 2 up, 3 plus 2i, and A is negative 2 plus 6i. W then is A plus B. Add them together, 1 plus 8i. Make sure you mark that point on our Argand diagram. So W is sitting up here. Right, question C. It comes in 2 parts. The first step gets us to achieved, and we complete the question to gain our merit. So we need to be good at our calculators here. The first step with Demeyev's theorem is to get from rectangular form to polar form. And we can do that in our calculators. There's many ways, but one way is on the calculator, going through that sequence option F6, angle F6. The 2 and the minus 2 has come from this 2 minus 2i. Our first step is to take the 4th root of 2.828 and multiply negative 45 by a quarter. That gives our first answer, 1.68, cis negative 11.25. Now, that stage we're on achieved. Because there are 4 answers, they are divided equally around the circle with a separation of 90 degrees. 360 divided by 4 is 90. So I'm just increasing the angle by 90 degrees. Negative 11 plus 90, 78 plus 90, and 168 plus 90. 4 answers takes us to merit. Now in our question D, we're going to use the conjugate. There's 2 different sets of notation used. Here in the question they've used U with a star above it for the conjugate. More commonly it's got the line above the U, as I've put in that little red bracket. Whatever, the conjugate is just where you change the sign between the real and imaginary parts. So if we're starting with 2 plus 2i, conjugate 2 minus 2i. Now when we subtract the conjugate, you guys are really bad at putting brackets around expressions. Put a bracket around the 2 plus 2i and brackets around the 2 minus 2i. That negative between them makes it a plus 2i, and we end up having plus 4i. So it's 2 minus 2 and 2i plus 2i, making 4i. And now multiply that by 4i, so 8i plus 8i squared, and of course I squared is negative 1, so it's 8i minus 8. Now the next step is to find the argument of that. And as always, there's going to be many ways to do it. Perhaps the simplest is straight off the calculator here, the argument of negative 8 plus 8i, answer 135 degrees. Degrees or radians, doesn't matter, whatever's equivalent. Now I'm going to skip down to question 2, and I'll answer any questions on the excellence parts in class time. We're trying to find the remainder when we're dividing by x minus 3, so we start by x minus 3 equals 0, x equals positive 3. The remainder then we get by substituting 3 into the original expression instead of. Okay? It's quite important that you know this remainder theorem and its similar version, the factor theorem. It saves a lot of time, and it's just the correct way to do it. So remainder when x equals 3, 3 cubed minus 2 times 3 squared minus 4 times 3 plus 8, answer 5. You'd get the same by long division. This is the quicker way to do it. Question B is actually quite a quick question. Modulus and argument of W. W is U divided by V. Now we can do that the long way we're using conjugates, a bit like question 1a, or here we can just do it on the calculator. And again, making sure there's brackets around those terms. 2 minus 2i in brackets, divided by 1 plus i. Answer, negative 2i. Now it's really important that you can plot your complex numbers on the Argand diagram. Negative 2i, it's like plotting the point 0, negative 2. So it's just negative 2 on the y-axis, or in this case the imaginary axis. The length of the line from 0, 0 to negative 2 is 2. That's the modulus. So the modulus is just the distance from 0 to negative 2, and the argument is the angle anti-clockwise from the x-axis, what I've shown with that orange sector. Okay, so the angle, or that angle indicated there, 270 degrees. Modulus is the length, so it's not negative 2i, it's just 2, and the argument 270. Or again, something like 3 pi over 2, anything equivalent. To find the roots of an equation, what we're doing is we're going to solve the equation. Now here we've got two fractions, and our first step will get a common denominator, and to simplify that left-hand side. So with a common denominator of x to the power 4, 3 over x to the power 4, and I'm going to have to multiply the top and bottom line of the second part by x squared, 2x squared and x to the power 4. Numerator 3 plus x squared over x to the power 4. And our next step will be just to cross multiply, giving 3 plus 2x squared equal x to the power 4. Solving, finding roots, put it equal to 0 and factorise or solve whatever method we can need. Okay. This step, this is one of the questions where we need to recognise that's actually a quadratic equation. By putting y equal to x squared, the question just becomes y squared minus 2y minus 3. And we can solve that any way you like. Formula, quadratic equations, doesn't matter. Here I'll just use the calculator, negative 1 and 3. But y equals negative 1 or 3 are not the answers to the question. We did a substitution, x squared equals y. So now we do it again. X squared equals negative 1 or 3. We're in complex numbers. So if x squared equals negative 1, the square root of that becomes plus or minus I. And x squared equals 3 plus or minus square root 3. The first step for any of these questions that talks about locus is to replace the z with x plus iy, and then take care of whatever algebra is needed to simplify it. So to work out the modulus of z minus I, we now look at the modulus of x plus iy minus I, and then we're going to collect the real and imaginary parts. Imaginary parts are any piece with the letter I in it. So the iy and the minus I, see how I've taken the brackets, and the imaginary part is just going to be y minus 1 in the bracket, and then you've got the I after it. And then to find the modulus, it's a bit like using Pythagoras, where you do the real part squared plus the imaginary part squared. X squared plus y minus 1 squared. And now we've got to think about our conics, because that's where this comes back into it again. If I squared each side, it's still 1, but the right hand side becomes x squared plus y minus 1 squared, which we need to recognise is the equation of a circle, centre 0, 1 and radius 1. And that's what I've drawn on the right hand side there with that orange circle. Question 3a. Now this one makes us work a lot harder to get our achieved mark. Our first step, if we know something's a factor, like we know 4 would be a factor of 24, then the other part of that, 24 divided by 4 is 6. 4 and 6 are the factor pair. It's a bit like that here. We know z minus 1 is a factor. What times z minus 1 makes that z cubed plus z squared plus 7z minus 9. And I'll find that by dividing into it. So we need to do a long division. There's a quicker method called synthetic division if you remember that. I'll show you that if you need to. So long division, z minus 1 and 2, z cubed plus z squared plus 7z minus 9. And we end up with z squared plus 2z plus 9. And see how I've got that 0. So that gives me, or indicates that was a true factor. Now, I'm going to come back to the z squared plus 2z plus 9, and I've got to solve that now. So from z squared plus 2z plus 9, I'm going to use the quadratic formula, negative b plus or minus b squared minus 4ac over 2a. And that has come down. Now when we're simplifying this, make sure you're okay to get from our square root of negative 32 down to 4 times square root 2i. That's sort of the key to this thing, because that's where we get the a plus square root bi into it. The next thing I have to do over here is just be careful with my cancelling, and the negative 2 plus 4 all over 2 cancels down to negative 1 plus 2 plus or minus the 2. Okay. So when we give our solutions, make sure that you give the 3 solutions. You've got z equals 1, which a lot of you missed in that exam, and the pair from the quadratic equation, plus negative 1 plus or minus 2i. So question B, fortunately that's just a little bit quicker and easier. We've got p minus q conjugate, and once again, as long as we put our brackets in there, we shouldn't have too much problem. So we're going to have p minus q, and the q is going to be in a bracket. So it's 10 plus 8i minus 3 minus I, 7 plus 7i. Finished. Question C, solve for x. When we have fractions involved like this, our first step is going to be to cross multiply. Now, what you always have to watch carefully here, those two expressions are underlined in red. They're actually just the difference of 2 squares. So when I cross multiply, it's like I've got over there in blue. I've got a minus b, a plus b, a squared minus b squared. And that's exactly what happens with these two terms when they multiply together. And so I've got, instead of a squared, I've got the square root of 1 plus 2x squared, or 1 plus 2x, and minus 2 squared. Simple equation from there. Collect terms, solve, x equals negative 4. The key to question D is realising what the question's actually asking. What it says in the text there, find the 2 square roots of the complex number square root 3 plus I, is really saying solve z squared equals square root 3 plus I. And so we're going to use the Miles theorem. This first part of the question at square root 2 cis 15 is a achievement grade question, or achievement level. And to get the merit level for these this question, we want 2 solutions. 360 divided by 2, 180. So the 2 solutions are 180 degrees apart. Cis 15 and cis 195.